This is a Jackson Pollock by a stormtrooper, as you can see. That's the splatter artist they always miss. There we go. I don't know who passed the bio. Now it's 13 years in IT and cybersecurity. Senior manager of pen test at Moss Adams, author of Hacking APIs. In addition, I'm the founder and chief hacking officer of AppySec University, which is a completely free API security educational platform. We have 5 courses on there now, including my API pen test course. And then I was also an OWASP contributor to the latest version of the API Security Top 10. I'll have a link to AppySec University at the end. So why are we here today? We're here to talk about why you should start hacking APIs. Not just as a pen tester, bug bounty hunter, but also as a business. If you have an enterprise vulnerability management program, very good chance you're testing one of the world's leading attack vectors incorrectly. A lot of the tools out there don't work, and I'll demonstrate that in this talk. So, why hack APIs? Why APIs to begin with? 83% of all web traffic is API related. That stat's a few years old. It's probably grown. Global API management market value is projected to reach $41.5 billion by 2031. Right now, well, that stat's old too, but recently, 46 million Postman collections, which those are defined APIs. Those are a collection of endpoints and requests that are all API related. And then in addition to all of that, APIs, as I'll show, are the path of least resistance, which is why they're one of the leading attack vectors. So what's the state of APIs? More and more organizations of all sizes are depending on APIs. Orgs across industries are depending on APIs. API testing is a top priority, but just not a security testing priority. This is all from the State of APIs report that Rapid API puts out every year. Participating in the API economy is a top priority for my organization strategy. So they polled, I don't know, thousands of organizations, maybe less, and this is how they responded to all of these questions. All of these orgs were somehow participating in the API economy. If they weren't, they still were, they just didn't know it. API testing is important, sort of. So 46% say, yes, we're using tooling for APIs. 36% are writing tests in their code. Some plan to. These bottom ones are relatively depressing, but they plan to, no and they don't plan to, no and I don't know what API testing is. But then once you get to the bottom of it, what type of testing are we even talking about? Well, for the most part, everyone was talking about functional testing, integration testing, acceptance testing. Security testing, it's 4%. Last year, it was 4.5, so it's on the downward. So, why are APIs a leading attack vector? If we look at the classic hacking process, we have to discover entry, we have to find a way to gain access, we have to get past the firewalls, the web application firewalls. We have to land inside the network somewhere, have command and control, be able to communicate outside the network. We have to pivot through the network, find the data, exfiltrate the data. Go through the entire kill chain. Let's see. This is the MITRE attack framework. And when we're talking about everything beyond this point, it's really this one highlighted spot, which is just a method of gaining initial access from MITRE's perspective. But from my perspective, this is everything because you don't need to do the rest. You don't need to bypass the firewalls. You don't have to pivot around the network. You don't have to be domain admin. With a lot of the vulnerable APIs that are out there, most of it is using the API as it was designed with the tiniest black hat on, where you just consider it from an attacker's perspective. Now I can use the API, but how can I use this maliciously? And the hacker mindset has been a big problem for organizations. I solve it at the end of this talk, so stick around and you'll find out how you can too. So in the API hacking process, this is a marketing document put out by our Chief Marketing Officer, Dan Barahona. The classic cyber attack versus the API attack. Oversimplified as Chief Marketing Officer. That's what he's there for. That's what he does. But here is the API testing methodology that I use. So first up, we're going to discover the API, which can be done in those initial scans that MITRE had in the first column. You could do some recon. Once you've discovered the API, you're going to see if it's documented. So this, APIs are a business enabler. They're meant to be consumed by other businesses, by partners, inside internal networks, privately by developers. It's just a method to transfer data easily. One second. Okay, so once you discover an API exists, it's consumable. It's meant to be consumed by other businesses, partners, other users. So what do we do on the internet? We make it easy to consume by providing documentation. If you're on a website, at the bottom, you can have that little link that says API, how to use. And then you can download a Swagger file or a Postman collection. And if none of that's available, you can just use the use the web application as it was designed, proxy all the traffic, and then you can build out your own documentation, which in the API Pentest course at AppySec University, I have a section on how you could do that. From there, you're going to use the API as it was designed, gain access by getting credentials, tokens. These could be leaked in GitHub repos, or if an API is meant to be consumed by other users, then you can create your own tokens. Then you're going to go through, set the parameters, receive successful responses, use it as it was meant to be used, and then you can start poking at it for weaknesses. So this is in the form of authentication. You just went through all that trouble of gaining credentials and tokens and everything else. Well, now that you have the collection built out, can you use any of that without the token? We'll see some breaches here in a second, where this is a valid test. Even in our own testing and in Alyssa's talk yesterday, you go through authenticated, you find a vulnerability, and then you ask yourself, what if I remove the token? And then you're still able to access it, and then you have another finding to write up. So you perform authentication testing, authorization testing, you go through, you make a bunch of resources as user A, group A, partner A, and then you go into partner B, and you see if you can access those resources, delete them, edit them, so on and so forth. From there, you fuzz everything. So you can fuzz headers, request methods, everything in the put or post body, and parameters as well. Also, one big issue with APIs is versioning. It's referred to as improper assets management. And with this, old, unsupported versions of the API can still be out there. And so if it's on version 3, then you're going to go through, test out version 2, version 1. Maybe UAT is available, test, mobile, admin. From there, you're going to check those out and see how the API responds. Then you're going to exploit the API and prove your concept. So you have a small finding, what can actually be done with it. You can make a successful request to version 1 and they're on version 3. Okay, did you find anything significant? Anything that could lead to a data breach? And then you're going to report your findings. So with all this, you can get through these steps to the end and compromise the data of everything that's being shared over that API with a vulnerable provider. You don't need to get in the network. You don't need to get past firewalls, maybe a web app firewall, maybe. You don't have to get domain admin. You just use the API from the internet often, and you can compromise what you'd be looking for otherwise. So this is T-Mobile from January 5th of this year. A bad actor obtained data through a single API without authorization. 37 million customer accounts compromised. Bumble. The API permitted access to 95 million user accounts without authentication. Incremental IDs were used, so it made it really easy to obtain that data. API allowed paid features to be enabled without proper privileges. Not good for business. And then Optus. So this is one of my favorite recent breaches that happened. So what happened here is an API was used without authentication to access one endpoint. That endpoint, the attacker was able to swipe close to 10 million user details. But what they did from there is interesting. They started to leak the data in a ransom event and said, unless you pay me $1 million, I'm going to keep leaking this data until it's completely out there. The data included driver's license, Medicare, IDs, name, phone number, email. Optus is also the largest or second largest telecom provider in Australia. So what's going on? Some experts say Optus may be the worst data breach in Australia's history. Fact. A lot of these are facts, which they're going to contradict each other, and it's going to get interesting. The Optus chief executive called it a sophisticated attack, saying the company has very strong cybersecurity. I believe that's a fact. The Australian cyber minister, however, has a contradictory fact. What happened at Optus was not a sophisticated attack. We should not have telecom providers in this country that have effectively left the window open for data of this nature to be stolen. So how can both of those facts be true? The chief executive responded to this. We have multiple layers of protection, so it is not the case that we have some sort of completely exposed API sitting out there. That part, not so true. That happened. But with these facts, yes, the organization, the second largest telecom provider, or largest, whatever it is, they are paying a lot of money for security. They do have multiple layers of protection. I believe all of that to be true. So why is this going on? Companies are confidently insecure in their APIs. Well, they think they're secure in the APIs. They're not. No Name, one of the leading API product providers out there, they have this survey they do. 71% of responders report confidence in their API protection. 67% are confident in their tools. Meanwhile, 76% experienced an API security incident within the last 12 months. Same thing that happened to Optus is going on all over the place. This is the problem. False negatives are the worst. So, false negatives, tests say you don't have it, you really have it. That's the false negative. And so what's going on is a lot of the tools that are being used and have been used for years, they don't work for APIs. And so these are a lot of those tools that are scanning CTF labs of deliberately vulnerable APIs. They have the entire top 10 of OWASP API security top 10 findings are present in these apps that are being scanned, but the findings are not there. This is at their worst. So this is just generic scan. You put a URL in there and you hope for the best. And then you take this back to your PCI compliance And you go, see, we don't have to fix anything, no findings. And they say, you're compliant. It's a lot of what the organizations are going through. Automated scans at their best. So not only did I do the worst, but I proxied all the traffic. I took my time authenticating, getting authorization, going through the app, clicking on every button, making every request that I could find. And here we have another scan. And so Burp Suite, one of my favorite tools, love PortSwigger, use it, but the automated scan by itself doesn't have the definitions to even cover the OWASP top 10. None of the tools do. And so you get some findings here. Unencrypted communication, interesting. Cross-site request forgery, interesting. These are things that should warrant additional testing. But again, we're not finding all the top 10 vulnerabilities that are on these apps. So, a key responsibility of the Enterprise Vulnerability Management Program, or QA in your developers, this is to make sure that the tools that they're using sufficiently cover your attack surface. And you can go in, the latest version of the OWASP API Security Top 10 has CWEs for all of the findings. Burp Scanner, they also provide all the CWEs for their scanner. And you can go through, compare them, and see what's missing, which is most of them. Scanners are really good at picking up security misconfigurations, but scanners are not so good at authorization testing. So going through as a user, making all those resources, making all the requests, knowing what the resource ID is, where it's used, and then going through as another user and safely attacking that. So this is my list. It's a little different than the OWASP top 10. But there's a lot of crossover. And so for me, one of the biggest findings, or the most important, is information disclosure. You can't really do anything without information disclosure. So without knowing how the API is responding, without those verbose responses, it makes it very challenging to figure out. But the problem is the API providers are not going to get away from this because it's meant to be consumed by end users. So it has to be friendly. It has to be approachable. That's a common thing that has to be dealt with between the provider and security, which is we need end users to use it. That's why it's there. It's enabled all this business. And so finding the balance between helping the end users, having it be relatively hands-off, and not being a huge bill instead of enabler, they have to balance out how much information is the right amount to disclose to the end user to help them through it. Because as an attacker, once you get that information, you can go through and target the rest of these. So once I know those resource IDs, whether or not they're incremental, it makes it easy if they are, but it really doesn't matter because we're going to go through and create them. They should be complicated. They shouldn't be. They should be as public as they need to be. That's where you're going to get the authorization testing, authentication. Can it be broken in the classic ways that authentication has been broken since the creation of authentication? Bad password policies, password attempts, all that stuff. Whether or not, and APIs are especially affected by this, but whether or not all the requests are even going to care about authentication and authorization. BOPLA, new OWASP term, but it's referring to excessive data exposure and improper assets management, broken object property level authorization. I've mentioned improper inventory management, improper assets management, same deal there. Mass assignment in APIs. If you're going through and creating an account, the classic mass assignment attack is to add on a parameter like is admin equals true. And that's just like the tip of the iceberg. You can add all sorts of parameters. During a remediation, we may say, hey, you expose all of this information on your user registration page. You don't use half of it. You probably shouldn't expose it. Properties disappear, but we can still go back and add the properties to the request because the other properties haven't been whitelisted to only those specific items that are needed. Security misconfigurations, the tools out there, the scanning tools, they catch most of those. So good job. SSRF, anytime a URL is being passed in a request to request resources from another source, can you manipulate that URL? Can you pass 127.0.0.1 and start requesting resources from that server? Maybe some file directories that you shouldn't have access to? Can you make it request resources from your malicious server that has a bunch of bad stuff hosted on it and then have it download all of that for you? And then you can get back on that MITRE attack framework. Business logic flaws. Are there features of the API that are they can just be exploited by using them? Lack of rate limiting. Can you make an unlimited number of requests? Those do have a cost, whether that's big or small. You see that especially effective. Rate limiting number of requests that you can make within a certain time parameter can also come in another form, which is unrestricted access. And with that, over on the GraphQL side, you normally send one request for everything you want instead of individual requests like a REST endpoint. So with that lack of rate limiting, can you make a circular request that's having the server request for resources that are being requested for, and if the server doesn't expand, the server just crashes, but all of us scale now, and so what happens is you just get a gigantic bill at the end of the month, and then you have to figure out what happened while there was unrestricted access or lack of rate limiting. So here's what the enterprise vulnerability management tools do. They detect security misconfigurations. Every now and then, you may have an authentication finding for an API, information disclosure, SSRF, every now and then you miss the rest of it. So how do we test the gaps? For authorization testing, you go in, you create the resources, then you attempt to use CRUD, create, read, update, delete, as another user. This isn't just restricted to users though. You can think beyond this. You can go with groups and users. There are a lot of combinations of things that you could use in order to attempt to get those resources. So is something in the URL path, instead of a version, do you have the partner name up in the path where you can attempt to, as user A from Google, to go into Apple's partner track in the directory and request their resources? Was that the layer of security by obscurity that they were depending on? So the development team has to make sure that users are only able to alter and access resources that belong to those individual users, typically tying it back to the authorization token. Authentication. So are there weak passwords? Can you create a single-digit password? That's bad. You shouldn't let your users do that. We don't in web apps. Why do we let them in APIs? Don't do that. Can authentication be bypassed altogether? Are there attempt lockouts? All those standard things. So like everything that we all worked on for web apps for years, and then APIs came along, way cooler. Everyone moved over to APIs, and they forgot about security. And so all those things that were worked on, insecure over on the APIs, and it has to be tested for, just like it did in the web app. There's something about an API being just beyond the GUI that has that layer of security. That's my thought. Maybe behind the scenes, they're not going to see it, so they're not going to be able to attack it, something like that. The tokens themselves, so we're depending on these tokens for authorization. Are they predictable? Are they complex? JOTs, so JWT, JSON Web Tokens are in use all over the place. These are like, as soon as I see those, it's great. You can take it, they're base 64 encoded, So it's not encrypted. So you can just go and look at what's in the payload. You can see the usernames. You can see sometimes passwords are passed along with those. You can see important IDs that you're going to go back to authorization testing, and you're going to test out some of those unique IDs that you find. Then the JWT itself, can that be manipulated? So there are plenty of attacks that you can do against JWTs. They use secrets, so just like anything else, can you guess the secret? Are there checks going on the server side where it's even looking at the signature, which is the important part of the JWT, because that prevents you from being able to manipulate the data within the payload and then just base64 encoding it again. Can you use your API, use the API and then use it maliciously? So use the API as it was intended, analyze the response. Does the API return too much information? One of the weaknesses, BOPLA, excessive data exposure. You make a request, it sends back everything. This one is pretty common. You make a request to a forum, and you can see all the users, all the emails, user IDs, multi-factor status, things you wouldn't even know that would go in there, but it's part of the data object, so the whole data object is being sent back, hoping for the client end to filter it all out. Improper assets management, inventory management, same thing. Make sure that the supported API versions are the only versions available. So if you think of unsupported software versions, Windows XP, and Windows XP is just still being used across the enterprise. The same thing if you fixed SQL injection in V1, but now you're on V3, but V1 is still available. And so making sure to have a life cycle where those are turned off when they're no longer in use. Also on this side, you can see the support of way too many versions of the same API. All of those versions have to be supported, and that's additional security budget, additional work from all the teams that are supporting it. Turn off the versions that are not being used by your end users and are no longer supported. Fuzz everything. We would hope the scanning tools would do a better job at this, but they don't know how, after they fuzz the thing, to determine that the request is interesting and can lead to some sort of exploit or breach. So fuzz the inputs, post body, query parameters, headers, all the things, down to like thinking through the business logic. I like to do this with banking apps. Can I transfer the global GDP to a user's account? There's no business case for that. Shouldn't be able to do that. Can I transfer negative dollars? What happens then? There should be very specific restrictions around what amount can be sent and what amount you want sent over your API to begin with. File uploads. So this is another thing that seemed pretty locked down on web apps, but moved over to APIs, and all the fun is back. You can manipulate extensions. You can upload any file you want to. And the next step is, can you now access that to execute it? That's the risk. But did your business get into the business of being Google Drive? Did you mean to be able to host everything all the time? Probably not. So the same restrictions that were on the web apps need to go to the APIs. The file type needs to be restricted. The size needs to be restricted. I shouldn't be able to send 50 megabyte files every second for infinity. So here it is, the API hacker mindset. We've been saying to introduce this into design in the boardroom forever. You don't have to do it anymore. ChatGPT can do it for you. And so I use this prompt. It's actually very useful. You're an API security expert, powered by all the things. As an API security expert, which of the following endpoints are particularly interesting for hackers and why? And it does a really good job. I'm like, I would have picked these myself. But it also gives you justification. Useful. So there's the prompt again. In this case, I fed it the Reddit API, which has 150 endpoints or something. So from a single end user perspective, that's going to take a while to get through, figure out what's interesting, what I should focus on. ChatGPT filters through all those endpoints. I just fed it the whole thing, and it said, hey, check these ones out. And here's why. And I like these. Private messages, administration endpoints, those are what I would look for. So, why API first hacking? API requests make up a lot of the internet's traffic. APIs are the path of least resistance for adversaries. The data that APIs interact with are often the most valuable, the keys to the kingdom, the thing that we're breaching. The firewalls, we're getting in, we're getting to the databases, we're trying to exfiltrate the data. You don't need to do any of that. You can just use the API, get all the data that way. API traffic, this is increasing all the time, 681%. US companies faced a whole bunch of losses linked to web APIs, $12 to $23 billion. So what do you need to do? You need to earn the confidence in your API security. Use baseline scanning tools. You don't have to get away from that, but you do have to use the right tools and techniques to make sure that the APIs are properly tested for the things that affect them the most. Authorization, authentication, checking those old versions to make sure those are no longer available. Cover the gaps that are present, and test your tools. Test your enterprise vulnerability management program. AppySec University hosts deliberately vulnerable apps. You can just hit those if you want to. You can host them very securely in your own network if you want to. Point your tools at those. They should have findings, and if they don't, you're vulnerable. Then remediate and retest. And that is everything. Happy hacking. Thanks. And here at the end, these are some of the AppySec University courses that are available. Everything is free here as far as the content goes. And yeah, there's QR code.
Thank you very much. Maybe we'll take one quick question, because I know we started a little bit later than we were going to. So I saw this hand right at the beginning. So yes.
For your books, what do you want to, like, they're ready, so I can set it up whatever you want to do.
Cool.
Good morning. My name is Harsh, and excellent presentation.
Thank you.
I would just like you to ask, can you share like one of your coolest bugs in API, and what was your methodology to find it?
Yeah, so my favorite happened twice in a week with two completely different clients, but both are in finance. And with both of those, I was able to find the resource IDs for accounts, see all the account history, and transfer all of their money back over to my account. Now I'm retired. I don't do it anymore. No, I reported it. Yeah, but two like billion-dollar, multi-billion-dollar like financial organizations had those in their APIs, 2 in 1 week. Baffle broken function level authorization, so I was able to send a post request. I knew the right IDs, knew my own ID. Nothing is stopping it, just letting it happen.
Thank you.
Yep.